All right, good morning, BC Bears. I am going to answer an age-old question for you. I hope you like my format here. The question is, what is the integral from -2 to 2 of the square root of 4 minus x squared? And you're like, ooh, I can do this. I got this. All I'm going to do is go to my calculator and go math 9 -2 to 2. Make sure nobody's looking. Square root of 4 minus x squared dx. And I get this. Ooh, it's thinking hard. Look at that. Ooh, 6.28. And I'm like, ooh, I recognize that. If I divide that by pi, it's 2, pretty much. 2 pi. Hey, Mr. Mac, it's 2 pi. And you're like, oh, sweet. But haven't you ever wondered why it's 2 pi? I'm not ready to give you the title of this yet. Well, it's probably already the title. Then you say, no. What I'm going to do is I'm going to appeal to the geometry of the region. You're like, oh, yeah, appeal to the geometry of the region. But aren't you sometimes kind of tired of appealing to the geometry of the region? You know what I mean? Don't you wish that you didn't have to say, oh, look, it's a semicircle of radius 2, and a circle of radius 2 is pi 2 squared, 4 pi. Half of 4 pi is 2 pi. Well, of course it's 2 pi. But haven't you ever been tired of looking at this and being like, man, shouldn't there be some way to actually do an integral of this? So what I'm about to show you is a really cool way to do this integral all by yourself. So check it out. Option 1. This is called trigonometric substitution. Trig sub. This is a really, really cool process that I think your profs would like it if you knew how to do. Okay, so square root of 4 minus x squared. You're like, ooh, I got an idea. Let me turn this all into thetas. And you're like, theta, there's no u sub. I can't see anything here that I would do. But please look at this triangle. Which is kind of cool that to find the area underneath a semicircle, you're going to use a right triangle with variables that aren't even in the integral, which is really, really cool. And I'm going to say, all right, if I call this theta right here, and I call this x, and I call this 2, wouldn't this side, according to Pythagorean theorem, be square root of 2 squared minus x squared? And the answer is yes. So now you look at this and you say, well, if that's true, and I look at my trigonometric ratios here, and I look at cosine of this angle. Cosine of this angle is adjacent over hypotenuse is the square root of 4 minus x squared all over 2. And with a little bit of magic algebra, we now see that we can substitute out the square root of 4 minus x squared. I think that's okay. Square root of 4 minus x squared with, you can leave it on, with this 2 cosine theta. So here we go. I'm going to start subbing -2 to 2. Just surprised me. Square root of 4 minus x squared. So this guy here is going to become 2 cosine theta. Okay. But then dx. Now we know we can't just switch out the dx. So now I go back to here and I say, wasn't that interesting? Ooh, but then I look at this and I notice that the sine of theta is opposite over, opposite over hypotenuse. So that means x is 2 sine theta. And if x is 2 sine theta, that means that dx, which is this derivative right here, dx, will be 2 cosine theta d theta. So this dx becomes 2 cosine theta d theta. And then I go -2 to 2. Not -2 to 2. You know, since you just changed your integral from x's to thetas, you got to change your bounds as well. So here is our, I kind of like this form of it here. See how this -2 and 2 are x's? So if I put my 2 into here, when is sine 2 over 2? When is sine 1? Pi over 2 in my principal round. In my sine inverse, well, this is not a sine inverse problem, but when is sine first 1? Pi over 2. When is sine first -1? Or closest -1? Negative pi over 2. So now we've turned this into the integral from -pi over 2 to pi over 2 of this 2 and 2 is 4 cosine squared. And you're like, sweet, now all I got to do is integrate cosine squared. Well, not so fast because we don't really know how to do that. Certainly not 1/3 cosine cubed. All right. So now we need a little help from what we in math circles call a power reducing identity. Now, if you remember the double angle identities, sine of 2 theta is 2 sine cosine. That's kind of cute. But the cosine double angle identity has 3 flavors. Cosine squared minus sine squared. Not helpful. 2 cosine squared minus 1. Helpful. 1 minus 2 sine squared. I didn't mean to say not helpful. I just meant like not apparently helpful. So if we take this guy right here and we solve for cosine squared of theta is cosine 2 theta plus 1 all over 2. Now that's really interesting. Although now that I'm looking at this, it looks like 2 cosine squared would be an easier substitution, which is what you're free to do as a mathematician. You look at this and you're like, ooh, I see a nicer sub. I'd rather sub out that without that fraction. So I'm going to steal one of those 2's from the 4. So now 2 cosine squared is cosine 2 theta plus 1. So here we go. So I got 2 integral cosine 2 theta plus 1 d theta from negative pi over 2 to pi over 2. And now I'm going to go 2. Now my integral of cosine of 2 theta, well, my integral of cosine of something is sine of the something. And because it's just a simple little unchain, my derivative of sine of 2 theta would be times 2. Cosine 2 theta times 2. I don't want the 2, so I'm going to put a half. Plus my integral of 1 is theta from negative pi over 2 to pi over 2. And now I've got this. I wonder if this will be nicer. Now I've got this a little too small. Now I've got this. All right, I'm gonna leave that out there for a minute. So 1/2 of sine of pi. Ooh, that's 0. Plus pi over 2. Ooh, here it comes. Minus 1/2 of sine of negative pi, which is also 0. Woohoo! Minus pi over 2. Whoop. So now I've got 2 of this. Now sine of pi is 0. 0 plus pi over 2 minus sine of negative pi. Okay, hold on. Minus before the boom. Okay, so now I got minus, that one's 0. Now I have negative pi over 2. And that's good because now I've got 2 pi over 2 plus pi over 2, which is 2 pi. Hey, that's what we wanted. 2 pi. Yeah, it worked. Now that was cool. So this is called trigonometric substitution. There's all sorts of cool ways you could do this. So what I would like you guys to try to do is use this same procedure to show that the integral from 0 to 4 of 16 minus x squared is. Now if you think about this, this is a circle, semicircle of radius 4. And if we're only wanting the 0 to 4 bit, of course you can appeal to the geometry, but 4 is 16 pi, a quarter of 16 pi is 4 pi. So I want you to try to use this procedure-ish or any other way you can think about doing some sort of substitution to find out that the integral of this is 4 pi. Sometimes a textbook will say, use the substitution, x equals 2 sine theta to show that the blah, blah, and which is kind of cool. You could try this too, because you have to plug that into here and do some substitutions in here with some trig identity. I just really like trying to find it in the triangle. And of course, you could have flipped these two as well and try it that way as well if you want another way to try something. But a nice clean way of showing this appealing to the geometry of the region is much quicker, of course. But we in math are not about quickness. We're about understanding and seeing where things come from. And if we have such a clean answer like 2 pi, there had to have been a nice way to get there. So problem number 1, I would like you guys to try to solve this integral and show that it is equal to 4 pi. And I will write out a solution to it so you can check against it. I'll do a few different ways to it as well. And, well, no promises, but I'll do at least one. So enjoy. That is a trigonometric substitution.